In this video I'll illustrate some characteristics of math expressions, equations, and how the converter deals with equations. I'll run a script for it, which is a subset of the whole converter. That's why this style is here, which is normally created by the converter, but I had to add it here because this is a subset. I've opened all the style panels, so you can see that there are no styles here apart from these two and this one, but I think this can go really. So when we run this script, sorry, I'll just to show you, I'll highlight the inline equations for clarity. Like here. So here we have a fraction. Here is another fraction, a square root, an nth root, a square root, a fraction in a square root, so to speak. This is a square root in a fraction. This is a longer equation, just to see how it deals with creating space in a paragraph for an inline equation. This is an inline equation in its own paragraph. And then here are some display equations. Display math to display math, they are not numbered, and to equation environments which are numbered. Right, so I'll run this script. Okay, there we are. First of all, I don't need this anymore. This panel. You see all the math styles are placed in separate folders, separate style groups. So here there's a whole bunch of character styles. There's paragraph styles. We'll see them in place while we go through them. There's a table styles for fractions and sums, cell styles, and object styles. All the LMath style group is used for styles that are exclusive to equations. So how are these equations built up? Fractions, like this one, are tables. See, there's a table style fraction, and the table is in a text frame. It's very close fitting, so you can't see the table border because it's covered by the frame border. And this inline frame is lowered by an amount such that the center of the frame, where the rule is, the dividing rule, is at half the x height, and the script calculates that. The rule this rule is a cell style rule. Is in the cell style. Let me see here. Strokes. Yeah. See, that's defined in the cell style. Right. So that's a fraction. Yeah, so a fraction and a fraction is turned out to be fairly simple because it's just you recursively create fractions and they position themselves rather well, in fact. Roots. Here we have a root. A root has its dedicated paragraph style, SQRT. It's in a frame with an object style. And the rule is a rule above. A rule above in this paragraph style. So as you can see, these values, of course, depend on the especially the font, but especially the font size, the type size that you use. Here's an nth root. It looks like a bit. I'll hide this. This is an inline like the other one. It's a square root. Again, the rule is provided by the square root style, and this one, the nth, the root's argument, I think you can call it, is in a anchored object. You see, it's an anchored object, and the position is regulated by this one. If you want to change that, it's easier to do it here. You can either just drag it around, and this goes for all aspects of styles, including object styles, or you can use the cursor keys. So that's actually, I prefer cursor keys, just easier to position things. It is useful, by the way, as a side note, to set the increments of the cursor key to 1/10 of a point. So that way, if I tap the up arrow key, see, it moves up a bit. If you want to move a bigger distance, you include the shift key, so you hold down the shift key and then the arrow key goes, it multiplies it by 10, so then it goes by a point. Okay, that's this one. Here we have a fraction as the argument of a square root. This square root is, sorry, I should have mentioned earlier, this square root is just a character. This is from, this is actually in Minion. See this one here. This one is still the same character, but the script sizes it. Let me see here. So as a local override, this square root symbol is scaled up, and it's made a bit wider, and then it's lowered to get it in the right position. And again, the rule is handled by a paragraph rule. Here we have a square root in the nominator of a fraction, and again, so this is an anchored frame. This is an inline frame, and it's lowered to so that the divider rule sits at the center of the x height. Here, yeah. So here we have an equation. It needs to make space for itself. You can space here is determined by the wrap of this frame. An important item is that if you use fixed leading, then you must apply automatic auto leading to the character that this frame sits in. Otherwise you can't create space. Yeah, now we have this one. We can skip over this one. Here, sum. The sum sits in a table, a 3-row table. A paragraph style for the sum symbol, and by the way also a cell style for the sum symbol. The N has its own paragraph style and cell style, and the same of course for this one. And again, it's lowered to sit at the center of the x height. This integral is just a standard character. It may have been, no, it's not scaled or anything. The arguments of the integral are again custom frames. And this one too. So you can, if you don't like the position, you can just change it. And you must remember to update if you changed an item locally, like here. You must remember to update the style, redefine the style. That's here. Redefine style. Here's another one. This uses bigger braces. Oh, this is from the Stix2 font. Here we have, I should have mentioned, let me see, I think I can close these style panels now. Yeah, first, these display equations sit in their own paragraph style. It's just to have some space before and after. And now here, this is also a paragraph style. I forgot something else again. If you look again at the codes here, you see here this yen symbol. This yen symbol is in fact it's an inline object. It's it's a graphic line placed as an inline. The graphic line has no width, and it's about 6 points tall, and its function is to store the original LaTeX code, just in case something went completely wrong. Then you still have access. You still have access to the original LaTeX code. So here, if you open the Layers panel, then you see several items here: LaTeX code, and the original LaTeX code is in the script label here. It's tiny type, so this is the original. Just in case you want to go back, if it doesn't work, you just throw this away and you start again. Here you have the original. Then here we have two equations numbered. The number is on the right, which is at the moment is the only option, to have the number on the right. This is in an inline frame, the number, because the paragraph number is at the right, and InDesign's paragraph numbers can only appear at the start of a paragraph. So in order to get automatic paragraph numbering at the end of the paragraph, you take a separate paragraph style for the equation number, and you put the frame here, the inline frame, at the end of the equation. This paragraph style has its own list, and here is to determine the numbering and the appearance of the number are set in here. Well, this is just another variant again. So this is an outline of how equations are produced by the converter. It's all text, as mentioned earlier. You can style things internally. If you change the base font, everything in the equation changes as well. There is a good risk that you have to redo equations. So that's why it's important to get the font and the type size and the leading correct before you convert. Well, that's it.